This is just a quick video to help you when you're comparing decimals. Okay, the simplest way to compare decimals is to write the numbers right under each other with decimal points lined up like buttons on a shirt. So you notice over here, I rewrote the 15.32 and the 9.7. And there's my decimal points, they're the big buttons on the shirt. Remember to compare the whole number part first. Then, if they're equal, I start comparing the decimal part one place at a time after the decimal. So I'm just going for the whole number part, and I notice I got a 15 and a 9. 15 is larger than 9, so 15.32 has to be larger than 9.7. Go to my next one. I'm comparing the whole number part. I got a 4 and a 4. So I'm going to go to the next place. Since they're equal, I'm going to the tenths. I got a 5 and a 5. So they're still equal. I go to the next place and I notice I have a 0, but over here I have nothing. Nothing is really the same as 0, so those are really equal. 4.50 is the same as 4.5. Let's try another one. Compare my whole number part. I got a 3 against a 3. They're equal, so I'm going to the tens place. I got a 3 against a 2, and 3 is larger than 2. Right here, I know some people are going, but wait, you got way more digits over there. If I come over here on the shirt, let me change cover so you can see it a little bit better. If I come over on the shirt, I have the numbers written down. I would just be adding 2 zeros right there. Because the people who think, oh, 256 is bigger than 3. Well, the problem is this is 256 thousandths, and this is 3 tenths, and tenths are larger. So if I add those zeros, now people can see, oh, 300 thousandths is larger than 256 thousandths. Next one, compare the whole number. 2 against 2, equal. 0 in the tenths against 2 in the tenths. 2 beats 0. And remember, I can always add those zeros in right there. 1 against 0.99. There's no decimal point in the 1. Remember, that just means the decimal point is right after it. If I add those zeros in, it really doesn't matter, because in the whole number part, 1 is larger than 0. So 1 is greater than 0.999. 999 thousandths. It's almost a whole one, but it's not quite. If I don't have any whole numbers there, I know the whole number is always bigger than the decimal part. 4.8 and 4.088. Both whole numbers have a 4. Then we got an 8 against a 0. Remember, you can add your zeros in if you want. 23 and 4.765. Well, 23 would have a decimal point right after it, and 23 is larger than 4, so I'm done right there. 23 whole ones is bigger than 4 whole ones and a part of 1. 5.06, 5.3, they both start with 5 in my whole number place. I got a 0 against a 3. 3 is bigger. Remember, I could have added a 0 in there. 4.22, 4.022. Whole number parts 4 in both of them. 2 against a 0. 2 is larger. They both start with 3's in my whole number. I got a 0 against a 1. 1's larger. 17.006, 17.5. It looks like this one because it's got lots of digits, right? Let's try it out. I got a 17 in my whole number part. 17 in my whole number part. And I'm going to the tenths. 0 and a 5. 5 is larger. Oh yeah, because I would be adding 2 zeros on there to say 500 is bigger than 6. Check this one. Here's my whole number part over here, 23. This doesn't have a decimal point, which means it goes at the end, and that's my whole number part. So 34 whole ones is larger than 23 and 5/10. I never even had to go to the decimal. And when I add or subtract decimals, I line up the decimal points like buttons on a shirt, and we've already taken care of that in 2 previous videos.